So lesson 5, more simplifying radicals. This is going to be basically a summary of what we've done the past few days, but yucky, weird ones, so that you can say, well, what if they gave me one of these? Oh, it fits into what I know already. What if they asked me to simplify 8 over 5 root 200? No problem. Part of the problem, one of the reasons, Anthony, this is so difficult, is the way my math editor and most math editors work. When you write a fraction, don't write this down, and then you put a number next to it, most math editors put that number exactly halfway in the middle of the fraction, which to me is silly. It's confusing. When I see 8 over 5 root 200, what I really see is this. Can you draw a long fraction line? I see an 8 on the top, a 5 on the bottom, and a root 200 on top. That's really what that means. Because now I can clearly see what's on top and what's on the bottom, instead of having that root 200 sitting kind of in the middle. Where does it go? On the top. On the top. On the top. Now, Jack, what did the instructions say? Jack, I did it again. Sam, Jack sits there in my other class. Sam, what do the instructions say? Simplify. That means write this in simplest radical form. Reduce this radical. So let's put an equal sign. Let's rewrite the 8. Let's draw a fraction line. Let's rewrite the 5. We want to write that square root of 200 as something times something. And specifically, we want to write it as a perfect square times something else. Root 100, root 2. Root 100? Root 2. Now, why is that so nice? Because, Alex, my friend, what is the square root of 100? Yeah, this is really the same as 8 times 10 with a root 2 left behind and a 5 on the bottom. You with that so far? What is 8 times 10? 80. A 5 on the bottom, when you put something on the bottom, what mathematical operation is that really? It's just really 8 times 10 divided by 5. You don't worry about dividing, you don't divide a root by a number. It's numbers by numbers, roots by roots, but there are no roots on the bottom. What is 8 times 10 divided by 5? 6. This thing simplifies to 16 root 2 over 1, but I'm not going to write that. So if they give you a fraction, which they will, don't freak out. The root goes on the top, and then same old, same old. Oh, but then go top divided by bottom for your numbers. And if it doesn't work out evenly, just write the top and bottom as a fraction in lowest terms. So if you had a 5 on top and a 10 on the bottom, write it as 1/2 root whatever. B, also I changed this question, so you have to rewrite this one. B is negative 3 over 2 root 108. Negative 3 over 2 root 108. First thing I'm going to do is rewrite this as a negative 3 and a 2, and I'm going to let myself know that that root 108 is on the top. Root 108. 108 is what times what? 9 and 12? Marcus says, oh, not an 8, Mr. Dewick, a 2 on the bottom, that 108 is root 9, root 12. Now, he is both right and wrong. Can anybody see why we're not done? Which one? Okay, well, first of all, it's going to be a negative 3. Brody, what is the square root of 9? So that's going to be a 3, yes? And there was a 2 on the bottom. But what did you say? I can do something with this 12 too. How can I write 12 as what times what? Except, can you say the perfect square first? I always go root 4, root 3. Now, Marcus, I actually know that 108 is 36 times 3, and I know my 36 times table, but I'm glad you said 9 times 8, because does that show you, someone was asking about it, do I need a calculator earlier? You can hopscotch your way down if you don't know your 49, well, your 100 times table. You can hopscotch your way down. Try 4s, try 25s, try 9s, try 49s. That bails you out of most stuff. You okay with me? Hey, what is the square root of 4 sitting there? See it, see it, see it? So this is really a 2 times a 3 times a negative 3 divided by 2. What's 2 times 3 times negative 3? Negative 18 divided by 2. This works out to negative 9 when you do all the number parts and take the square root of whatever you can take the square root of. What's left behind inside the radical? And Greg, you can also use your calculator to check your answer. You can go try that again. Negative 3 divided by 2, because that's what 3 over 2 is, times the square root of 108. I get that as a decimal. If I go negative 9 times the square root of 3, which is what my simplified answer is. Amy, do I get the same decimal? It must be right. C. 10 root 27 x to the 4th. Okay. It's not a fraction. That's good. Well, let's start out by changing colors. Let's rewrite the 10, because that's already outside the radical. No problem. And then let's do the numbers inside the radical first, Garrett. Then we'll do the letters one at a time. So let's do the numbers. 27. Can I rewrite that as a perfect square times something else? This is root 9, root 3. X to the 4th. Is x to the 4th a perfect square already? Oh, so I don't need to rewrite it. I'm just going to write root x to the 4th, and I will take the square root of it on the next line. Because I think I'm going to get this. A 10. Duh. What's that root 9 going to become? There's going to be a 3 in front as well as that 10 being multiplied together. Can I do anything with that root 3? That's going to stay right there. But can I take the square root of x to the 4th? There's going to be a x squared outside the square root as well. See it, Simi? In terms of the numbers in front, I'm going to have that times that times that. It's going to be 10 times 3 times x squared. In front of everything, I'm going to have a 30 x squared, and left behind inside the radical, a root 3. D. Square root of 12 over 25. Ah, no, relax. It's a fraction, Mr. Relax. Look up. Put your pencil down. What do you think the square root of 9 over 16 is? 3 over 4. It's square root of the top over square root of the bottom. It's going to be square root of the top over square root of the bottom. Ooh, I like the bottom. It works out evenly. What is the square root of 25? Just 5 root nothing, not 5 root 5, just 5, no more root. So on the bottom there's going to be a nickel, a 5. And Brody told us earlier we can do something with a root 12. What can we write root 12 as? Root 4, root 3. And Brody, what is the square root of 4? This is 2 root 3 over 5. Now, if I was typing that using my math editor, that's where it would write it like this, with the root kind of halfway. Well, like the first example that I did up here. So just don't write it that way. I think it's a dumb way to write it, but I'm stuck with the software. Anyhow, let me erase this. Have I really done anything new today? I think we're just looking at weird, different questions, but we're still saying same old, same old. E. Ooh. Ah. What kind of a root is E? Cube root. Okay. For square roots, I wanted to rewrite it as a perfect square times something. For cube roots, what do you think I want to rewrite it as? Perfect cube times something. Now, what are the perfect cubes? You know what? Let's jot them off in the margin here. What's 1 times 1 times 1? What's 2 times 2 times 2? What's 3 times 3 times 3? 4 times 4 times 4? And 5 times 5 times 5? Those ones you kind of want. So, smarty peoples, how can I write the cube root of 24 as what times what? Don't say 4 times 6, because 4 is a perfect square. I don't want a perfect square. I want to write it as something from that list in red. Cube root of 8, cube root of 3. Oh, what is the cube root of 8? Two. What's left behind inside the cube root sign? 2 cube root 3. Hey, what if instead of a cube root, what if it was a fourth root? I wouldn't be looking for perfect squares or perfect cubes. I'd be looking for perfect fourths, which means I would look for, well, 1 is kind of redundant, but 2 times 2 times 2 times 2, 16. 3 times 3 times 3 times 3, 81. They probably won't go much past that. 4 cube root 54. 4. I want to write 54 as something times, the cube root of 54 as something times something. And don't say 9 and 6, because 9 is a perfect square, and we're not dealing with perfect squares here. Ours is the cube root. Yeah?
Cube 27 and cube 2.
Turns out it's cube root 27, cube root 2, because 27 times 2 is 54. How's that help? Well, there's still a 4 in front. What is the cube root of 27? What times what times what gives me 27? 3. And there's a cube root of 2 left behind. Oh, so I'm not going to write 4 bracket 3. What will I write instead in the front there? That's a 12. Cube root 2. You can probably expect on your test a few higher order roots, like cube roots and fourth roots. Not a bunch, not 10, probably not even 5, but probably more than 1. So I guess that means 2 or 3 or 4. Because I said not 5 and I said not 1. I guess that narrows it down. So that was going forwards. We also said, Brady, you can go backwards. Now, going backwards, we said you could be asked to rewrite the following as an entire radical. What's an entire radical? Nothing in front of the square root sign, everything inside the square root or the cube root or the fourth root. In other words, not something root something, but just plain old root something. As an example, A. Suppose I said simplify, and you got an answer of 8 root 10. Where did it come from? Well, what's in front? Where would that 8 have come from? What must I have had here to get an 8? It must have been a root 64 in front of the root 10. Yes? Oh! Which means I must have had my original question being what? Root 640. If I want to write 8 root 10 as an entire radical, 8 root 10 is 640. How do I know it's an entire radical? Is there anything in front of the radical sign?
No.
You mean everything is entirely inside the radical? It's entire. B. It says rewrite it as an entire radical. Okay. Where'd that 2 come from? How are you getting the 4 in your head, by the way? What are you doing with that 2? Squaring it? Okay. So you're saying it was root 4, root 5, which must have originally been what? Root 20. All right, smarty peoples. 3, cube root 5. I know. Can you add part C? 3 cube root 5. This one. Alex, is that big enough you can see back there? Big enough you can see back there, Garrett? All right. What's weird about this one? Cube root. Okay. Well, what number must I have had sitting right there so that when I tackled it, I ended up with a 3?
27.
And there's also a cube root of 5 sitting there, yes? So, what was the original question? The cube root of what? 135? Anybody else? How'd you get the 135? Yeah, we can multiply roots by roots. The original question must have been, hey, simplify the cube root of 135. And when they did that, they got the answer of 3 root 5. Cube root 5. Mixed radical? Entirely a radical. That was so much fun. Let's do another one. D. D. 4x squared cube root of 10x. Okay. Yeah. Well, I'm not going to panic. Let's see if I can figure this out. Sam, definitely we must have had cube root of something in the... You know what? Let's go one thing at a time. Let's do the numbers first. There's a 4. See it? Brody, there must have been one of those. There's an x squared. Where'd that come from? If I had an x, don't write this down. If I had an x cubed right there, wouldn't that have given me a single solitary x? How did you get this 64 from that 4 mathematically? You went like this. So wouldn't I go like that? Here's the question. What's the exponent? What do I do with that 2 and that 3? What? It's a 6. The cube root of x to the 6th is what gives you the x squared. Right click. Hang on. x to the 6th, and then I would drop the cube root, cube root of 10x. Jordan, do I have everything inside of cube roots now? Then I can multiply everything together. This is going to be the cube root of, let's do the numbers first, 64 times 10 in your head.
640.
Woohoo! Told you could, yeah. Excellent. X to the 6th times one more x. How many x's do we have? Okay. Not so bad. Now turn the page. What kind of application questions can they give you? Do you have a question that says, what is the area of a rectangle with length blah, blah, blah? Yes? Hey, let's try it. It says, what is the area of a rectangle with length 6 root 5 centimeters and width 2 root 10 centimeters? Give your answer as a radical in simplest form, which means, Greg, don't use your calculator. What shape?
Rectangle.
You know what? Let's draw a little picture. Thunk. There's my rectangle. And I guess the length is 6 root 5, and the width is 2 root 10, and it's a rectangle. How do you find the area of a rectangle? This you kind of need to know from like grade 9 and 8 and stuff. How do you find the area of a rectangle? Area is length times width, LW. What's the length according to this question, Marcus, my friend?
210.
2 root 10? Way to say it like a nerd. Actually, that's the width. What's the length according to this question? 6 root 5. 6 root 5? 6 root 5. What's the width according to this question? 2 root 10. 2 root 10. 2 root, okay, so I'm going to go like this. 6 root 5 times 2 root 10. Oh, we've done this already. Numbers by numbers, roots by roots. Numbers times numbers. 12? Yes? Root what? 50. Oh, ooh. Does that 50 simplify further? Is there a perfect square hidden in that 50? Because it did say, Brady, write your answer in simplest radical form. Is there something hidden in that 50 there? Did you nod your head? 50 is 50. 50 is what times what? Ah, I can write this as root 25. I can break this down a little bit further. This is 12 root 25 root 2. What is the square root of 25? This is 12 times 5 root 2. Hey, what is 12 times 5? This is 60 root 2. You know what the area of that rectangle is in simplest radical form? 60 root 2. That's one application they love to do. Another application they love to do is one that has squareds in it so that you end up having to square root when you're done. It's Pythagoras. Does anybody remember Pythagoras' equation? It's a fairly easy one to remember because it's kind of alphabetical. Ben?
A squared plus b squared equals c squared.
Let's write this down right here. A squared plus b squared equals c squared. What does that mean? There was one thing you had to remember for Pythagoras. What did the letter C stand for? It began with the letter H, rhymed with hippopotamus, sort of. Okay, the hypotenuse had to go where the letter C was. Now, what the heck was the hypotenuse? The longest side, the slanty side, the angly side. You got to be careful. The longest side, because in this diagram, all the sides are angled. I was mean. See, I know what you mean. Okay, so let's plug in everything else. A and B, it doesn't matter as long as you know that this right here is C. Usually then, I just do the first thing I see as A, yoink, and the second thing I see is B, yoink. And the equation is going to be 10 squared plus 24 squared equals mystery side squared. One of the oldest equations in history, at least 2,300 years old, at least. Hey, what is 10 squared? I can do that in my head. What's 24 squared? 576 equals x squared. So I think what we're saying is that x squared equals 676? Okay. How do I get rid of a squared if I know x squared equals 676? How can I figure out what x is equal to? Oh, Marcus, use the math word. Say it. Preach it louder, my friend. Square root. X is going to be the square root of 676. Now, the first thing I'm going to check is, does this work out evenly? Does it? Yeah. Oh, it does. If not, from now on, unless they say different, simplest radical form. Pull out any hidden perfect squares and leave the remaining roots inside the radical. This does work out evenly? What is the square root of 676? Okay. Second one. Pythagoras. By the way, how do I know to use Pythagoras? It's a right-angled triangle. It's got that thing right there. Pythagoras, Ben said, was a squared plus b squared equals c squared. And Kira said, Mr. Dewick, C has to be the long side, the slanty side, the hypotenuse. A and B, it doesn't matter. What's my equation going to look like? What squared plus what squared equals what squared? 8 squared plus x squared equals 10 squared. 64 plus x squared equals 100. Right, Jordan? Mm-hmm. Okay. I can't square root yet because the x squared isn't by itself. I need to get the x squared by itself. So we're doing a little review of equation solving now. How would I move that 64 over to the other side? Brody, how do you know? You're right. How do you know? Greg, you're in physics. What's the 64 doing to the x squared? Adding, subtracting, multiplying, or dividing? It's adding, and you do the opposite. That's how what you really ask is, what's it doing to the variable that I want to get by itself? Do the opposite to that number to move it over. Since it's plussing, I'm going to minus. And I think you end up with x squared equals 36.
Correct.
Can I take the square root of that? Yeah, this is the last one I tried to make work out evenly. I don't think any more will. X equals the square root of 36. It's 6. Let's try some now where we have to leave our answers in the simplest radical form. All right. Okay. Which one of these is C? Let's put a little C right here. Hey, we'll call that A. We'll call that B. What's my equation going to be? What squared plus what squared equals what squared? X squared plus 20 squared equals 30 squared. X squared plus 20 squared, 400? Yes? 30 squared, 900? Okay. Is the x squared by itself already? Nope. Okay. What's that 400 doing to the x squared? It's adding. So how will I move it over? Subtract. And I think I'm going to get x, well, let's keep going blue, Mr. Duke. Be consistent with your color. X squared equals 500? All right. How do I get rid of a squared? Brody. So I'm going to get this. X equals the square root of 500. And what we're saying is now we're not going to go to our calculator and say, oh, the answer is 21 point whatever. No. We're going to write this in simplest radical form. 500 is what times what? Oh, root 100, root 5? And root 100 is a nice number because I can take the square root of that. Yes, 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 yes. So this is root 100, root 5. In fact, in simplest radical form, what is x? What root what? 10 root. Yep. Another one. Why is this also Pythagoras? If you imagine chopping a rectangle diagonally, what shape do you get? A triangle with a right angle? Oh, cool. What are we trying to find this time? A, B, or C? Okay. I'll put a little C right here. How about an A by the 10 and a B by the 12? Or you can put the B by the 10 and the A by the 12. I usually just go from left to right, whichever one's I see first. What's my equation going to be here? Oh, Kira went straight to the numbers. And you know what? I'll live with that. So she didn't bother. What'd you say? 10 squared plus 12 squared equals x squared. Is the x squared by itself already? Yeah? So x squared equals, what is 10 squared plus 12 squared? 10 squared plus 12 squared? I don't think it's a... I'm skipping a step. I'm saying that go to your 244? Right? It's 100 plus 12 squared? 144 plus 100? 244? Marcus, how to get rid of a squared? Okay. X is going to be square root of 244. This is a tough one. What goes into 244? Does 4? Yeah. So can you go 244 divided by 4? What do you get? 61. Does 61 break down any further? No, in fact, I think 61 is prime, I think. So this is root 4, root 61, or in simplest radical form, 2 root 61. I have another question for you to add. In fact, they're probably going to do something like that. So draw yourself a lovely right-angled triangle. Psst, psst, psst. Hello. Draw yourself a lovely right-angled triangle like that. I'll make it a little larger for those of you in the back row. Where the long side, the hypotenuse, is 5 root 3 long. The short side is 2 root 3 long. And the medium side is x long. By the way, have I really done anything brand new this lesson at all? Have I taught you anything brand new? I think all I've really done is say, oh, here's another way to use this simplest radical form thing. Hey, here's another way to use this simplest radical form thing. That's really why the Math 10 Provincial is tough. It's not just tough because there's tricky concepts. It's you got to be clever. They're going to ask you something that's not new, but maybe I haven't gone over that one specifically. You got it written down? I've stalled long enough? Which one of these is C? Hey, let's call this A. Let's call that B. Is this a weird question, Anthony? Looking a little bit differently? Are the numbers looking a bit stranger? Then I'm going to be extra careful. I'm going to show a bit more work. In fact, I'm even going to start out by saying, just so I feel better, heck, I'm going to rewrite Pythagoras. Pythagoras said that a squared plus b squared equals c squared. I've written something down, Amy. It's no longer blank. I'm more relaxed. Amy, what's a? Squared. X squared. Okay, I can write that down, I think. Plus. What's b? I knew it. Sorry? 2 and then 3 is not how we've been saying this. How do we say that? Say it like a nerd. 2 root 3 squared. So I'm going to go like this. 2 root 3 squared. I'll come back to that in a second. Equals? What's 5 root 3 all squared? Remember I said I'm going to get a little paranoid here because this is a weird one. I'm going to go really, really basic. What does squared mean? I'm going to write that out because I'm not quite sure what to do. So I'm going to go x squared plus, and I'm going to write 2 root 3 times 2 root 3 because that's what squared means. Equals 5 root 3, 5 root 3. You with me, Sam? I don't know where we're going, but I can write it out. You okay with this line here? What does squared mean? So, 2 root 3 all squared would mean 2 root 3 times 2 root 3. 5 root 3 all squared would mean 5 root 3 times 5 root 3. Okay? How's that help? I don't know, but I'm got to try something. Hey, I'll rewrite the x squared again. Oh, we've kind of done this stuff before. How do we solve? Don't we go numbers times numbers, roots times roots? It's going to be 2 times 2. 2 times 2? 4. It's going to be a 4. And then what's going to be inside the square root? 6 or 9?
9.
9. Equals 5 times 5. I'm running out of room, so I'll move sideways. Ooh, hey, let's rewrite the x squared. What is the square root of 9 the same as when you evaluate it? This is really 4 times 3. Which is going to be what? 12 equals 25 times 3, because you said the square root of 9 was 3. In fact, I'm going to end up with this. X squared plus 12 equals 75. See where the 12 came from? Coming back to you. There is a shorter way that I'm going to show you in a second. But you should end up with a 12 and a 75, even if you did it a different way. The short way, by the way, is to go, hey, what's 2 squared? 4. What's root 3 squared? Just plain old 3. 4 times 3 is 12. That's a quicker way to get there. If you spotted that. We're not quite done yet. We're nearly done, but not quite. I want to get the x squared by itself. What will I do with that plus 12? You're going to go minus 12, and you're going to get x squared equals 53 or 63? 63? How to get rid of a squared? Can I break 63 down further? Ah, I can. Final answer. This is root 9, root 7, or in simplest radical form. There you go. Marcus says a lot of work for one question. Yep. Although there are some shortcuts that we'll talk about in a couple of days maybe. Or you might have spotted some. Folks, that's it. That's the unit. I have a big review assignment, a nasty one. I have another big review assignment and yet another one. And I'm going to be giving you a take-home quiz. So when do I see you next?
Next Wednesday.
I'll give you a take-home quiz on Wednesday. It'll be due the following Friday. You can probably expect your unit test to be maybe the following Friday or the week after that. We're getting close, though. What's your homework?